Okay, so here we are on the second day in the third lecture for 7.10. We don't have a lot to finish up, but it is kind of a very interesting concept. So let's go to right where we left off from your last lecture on 7.10. And as you can see here, we're going to do this. It's one of these kind of self-defining terms. The common ion effect is you're going to have two different actions, or reactions, and you add something to the system that has a common ion. It's going to have an influence on this equilibrium system. For instance, let's say you add, a pinch of salt to this equilibrium system. Well, you're not adding Na. You're not adding NaCl, that's not in there. You're not adding Na+. You're adding the chloride ion. So it's like when you dump something here, it will shift to the left. So this will cause more solid to be formed because of the shifting of this equilibrium. And that, of course, is Le Chatelier. As we move toward the left, and the equilibrium shifts in that direction. Okay, so you look for the common ion in these systems. So here's one we're going to crunch some numbers. So you have this little saturated solution, equilibrium system, right? Barium sulfate, 400 milliliters of it, and you dump in a pinch of barium nitrate. And as you can see, we do have a common ion in this system. So when we looked at our original system, 400 mils at that temperature, that was your KSP. And what we want to find is the moles that were originally in the system. Because then we added some more of the common ion, so we can use this KSP value to find these guys. They're in a nice 1-to-1 ratio there, so you can just for your molar solubility just use S squared, and so you're going to get the square root of 1.1 times 10 to the minus 10th. And that's going to be the concentration of each one of these after you find the square root. So 1.0 times 10 to the minus 5th is your original barium concentration. Now, obviously, if you throw in a pinch of barium nitrate, you're going to be adding some more barium to the system. Oh, I'm sorry. This it said find the moles. This is moles per liter, and we only had 400 milliliters, so it'll be a fraction of that. So the actual moles of the barium ion are 4.0 times 10 to the minus 6 moles. Okay, so now we got the moles of that original substance, and then, like I said, we added some more barium. So find the moles that were added. We're going to do this. You took this many grams. This is grams to moles. And this is an important step because sometimes if you're looking at this ion, like if I was doing nitrate, there'd be 2 moles for every 1 mole of barium nitrate. But I'm doing barium, and there's just 1 mole of barium per 1 whole entire formula unit. So those kind of are a wash there. So you take that 0.02 divided by the atomic weight of barium nitrate, and that's how many moles of barium that you added. Okay? So now you can take, well, I had that, just go back to right here, 4.0 times 10 to the 6. That's, you added that to this amount, and of course you're going to do the concentration, the whole thing, still 400 liters because you just added a pinch of salt to it, which is not going to significantly alter the volume at all. So you're looking at sig figs here, 3, 2, 4. So yeah, not a bad idea to do this in steps here, but so that's your barium concentration when it is at equilibrium. So notice the barium increased in concentration as you went through that system. So you go back to any of these chemical equations here. I'm not finding the right slide for the barium one. I guess they don't have the full. You don't need the chemical equation. They didn't put it. So anyway, that is what happened to the barium ion concentration. Now, step 4, find the sulfate in the final concentration at equilibrium. So in your chemical reaction, as you added barium, it'll be shifting to the left. So you can figure out that concentration by, we did the barium, we know what the KSP is, you just rearrange that guy, and then you can get the 5.5. So the sulfate decreased, because remember it was shifting to the left, it's going back to the solid side, so you should show a decrease in sulfate ion concentration. That's exactly what happened. Okay, so that's the common ion effect. Here is another example where we add some silver chloride, which will cause a shift to the left again. So here you're given this is a classic problem that they'll use to test this. So you have these two nitrates. You know they're very soluble. So basically what we're talking about is calcium ions and iron ions at different concentrations. And we start adding very slowly some sodium hydroxide, and we say, which one will precipitate first? Well, this is going to take some calculation. So what we're going to do is we're going to find the absolute maximum hydroxide ion concentration before it starts to fall out of solution. And to do that, you write your KSP expression, and then you just rearrange it to solve for the OH. That's why you had to take the square root given these quantities. So you take the KSP divided by the concentration of calcium, and this will be the OH max in molar for the hydroxide ions. Okay, so that will be different for iron hydroxide because it had a different KSP value. You can plug that in, and that was the concentration that was given, and this is the OH max when you're adding that FeOH2, and as it turns out, OH concentration, which you did for both of them, it's going to get to this before it gets to 7.6 times 10 to the minus third, actually quite a bit sooner. So the FeOH will precipitate before the calcium hydroxide. So you're going to get a chance to practice a couple of these. These problems are a little trickier, so I am going to post the answer key, and you do not need to submit them. Just make sure that you look and do as many of these problems as you need to feel comfortable with the KSP and the common ion effect. Don't take shortcuts, because we are getting closer and closer to that AP exam, and this could be one of your strong suits, this type of problem. So make sure that you know how to do these. So this is the video that hopefully will help you, and then the answer key will be there for you as well. There's a couple of decent videos, Khan Academy and some other ones on common ion effect, but I don't think that they're the best. So just look at these problems, look at the solutions, and I think you'll be in pretty good shape. All right, so that is the end of a 7.10.